Okay, so starting off with up there where it says example 1. Please listen. The first thing you're always going to have to do is to isolate the absolute value. That means you don't want anything in front and you don't want anything after the absolute value. This one is already isolated. Okay, what I'm talking about is maybe the negative 3 on example 3 or the positive 3 on example 2. So, what you're going to do, again, is you're going to take whatever is inside that absolute value, inside the absolute value bars. You're going to make two different problems, essentially. You're going to do 2x plus 1 equals 5. And then you're going to put 2x plus 1 in parentheses and a negative in front and set that equal to 5. Yeah. Okay, so let's make sure that we're good on just our basic algebra here. Tanner, on the one on the left up there, what would I do first? And then do what? Awesome. Mr. Worsley, what would I do on the second one first? On the warm-up, I told you to do this. Nope, do not distribute the negative. Absolutely do not. Somebody tell me what I need to do with that negative. Just told you on the warm-up. Divide it by negative 1. Okay, that is going to cancel out that negative and make this negative 5. And then now I'll do the same steps as I did on the first one. It's going to be subtract 1, divide by 2, but obviously my answer is going to be negative because, or it's going to be different because I got negative 5 over there first. So I've got 2x equals negative 6, and then x equals negative 3. Okay. Questions on that process? Okay, so if I go over to example 2, said before we started 1 that you always want to isolate the radical. So what would the first step be on example 2? Do what? What do I need to do with the 3? Divide both sides by 3 because it's 3 times the absolute value. The opposite of multiplication is division. And then once you have the absolute value isolated, now is whenever you split it up into 2. So I want you to attempt that one right there. Those should have been the 2 equations that you were setting up with. You would get positive 1 and negative 5. Looking at example 3, what's the first thing I would need to do? Divide by negative 3. What looks wrong about that? Kind of talked about it at the beginning whenever I was talking about distance. Comparing distance to absolute value stuff. You cannot have a negative answer to an absolute value statement after the absolute value part is isolated. So whenever I get here, if I get to this point and it's an absolute value of doesn't matter, equal to a negative number, It's no solution. I'm done with the problem. Okay? Do not be a robot on these problems and just go through the process without noticing what kind of numbers you're dealing with. Okay? In fact, you should be looking for that situation, because that means now I don't have to do all the extra work that I had to on the previous two. Important news.
Yeah, very.
Okay, so let's look at these two. Now we're going to look at solving it by graphing. Okay? And so what we're going to do is, and I'm going to graph these a little bit differently than I did last time. Where last time we talked about we did that and we did the transformations. If you like doing it that way, awesome. Do it that way. Okay? But I'm going to talk about graphing it a little bit different way. This is actually the way that I normally do it. But whenever we're solving it graphically, all right, you're going to, the solutions, and make sure you know how to find the solutions on the graph. The solutions are going to be where the two graphs cross. And so, what we will do is the first thing we will graph is going to be 2 times the absolute value of x minus 5 minus 4. And then y equals 2 will be the second thing. So, graphing the absolute value without the transformation way that we talked about last time. Can somebody, by looking at that equation, tell me what the vertex is? 5, negative 4. Okay. All you have to do is look at the C, which direction is that going to move the graph?
Negative 4 or 5?
The minus 5.
It will move. Are we gonna use, is it from the last packet? Is it somewhere like that? So it's
Yes.
right?
Right, 5.
Okay.
Awesome. Okay. And then, Malachi, which direction is that going to move it?
4. Down.
Down 4. So if you start from the origin, which is where the vertex of the parent function starts, you go right 5, down 4. That's where your vertex is going to be. Okay, so you have to know that from that, and a lot of times, if you come check your notes on the key, next to a lot of these, you'll have that written. You'll see that written, and I'm just writing the vertex of it. So 5, negative 4. There's my vertex. Now, I've also got an A value of 2, which is a vertical stretch. How do I put the vertical stretch on there? How do I graph that? Say it again, Trent. Rise over run. It's just like the slope of a linear line. So from my vertex, I go up 2, right 1. Up 2, right 1, and so on, until I run out of room on the graph. Once I have that part, I need to go back to my vertex, and it's actually the negative, that slope, but negative. So I'm going to go up 2, left 1, and graph all those. These graphs need to be accurate because you're finding two intersection points, and part of mine's off there. That right there. Questions on how I graph that? All it is vertex, slope one way, and then slope the other way. Yes, ma'am? Now I need to graph y equals 2. which it's going to review this again. Last time we talked about the axis of symmetry, which was a vertical line, and all of our axis of symmetry started off with what? Last class. X equals. Well, so y equals would be a what kind of line? A horizontal line where y is 2. So right there. And then the solutions to your problem are going to be the x values of those intersections. So we've got 2 and 8. So the first thing I'm going to graph is this. The next thing I'm going to graph is this. Somebody tell me what my vertex is. Do what? -1. If there is no d value, it does not move up or down at all. So it's -1, 0. Alright, so if my horizontal line is at the top, y equals 9, and the graph is down there, and the solutions are where the two graphs cross, my answer to this problem would be
No solution.
no solution. That is fabulous, Trent.
Why are you writing cursive?
Do what?
Why are you writing cursive?
It's easier.
Can't read it.
Sorry. Alright, going to this one. There's just a small typo on this. I want you to put equals 0. So your first one, you're graphing this. And your y2 is y equals 0. Okay, so on this, you're going to go -1, -4. My a value is 1/2. Don, Bree. So I'm going to go up 1, right 2. And I'm going to go up 1, left 2. Close the question over here. Where did I start? So I'm going to look at my vertex. And I'm going to find that by, this tells me to go left 1, and that tells me to go down 4. So I'm going to start at -1, 4. And then I have y equals 0, which essentially is just the x-axis. And so you should have gotten the solutions -9 and +7. Questions on that? Everybody good on graphing absolute value and solving it by graphing? Fabulous. Okay, let's go down to these last two problems. We're just going to do a small part of these problems. All we're going to do is write the inequality. Next class, we're going to talk about solving the inequality, graphing it on the number line, all that fun stuff, but right now we're just going to talk about writing the inequality equation that represents this situation. Okay? So, and I'll kind of connect it back to the warm-up that we did at the beginning. It says, a jewelry company manufactures a 16-inch bead necklaces The specifications allow for a difference of 0.5 inches. The function f of x equals the absolute value of x minus 16 represents the acceptable difference in necklace lengths versus the specification. Graph the function on the number line. All that says is the ideal length of this necklace is 16 inches. They allow a half an inch error on either side. So to connect it back to the warm-up, what two values on the number line are 0.5 away from 16? 15.5 and 16.5. So the shortest necklace they're going to allow is 15.5. The longest necklace they're going to allow is 16.5. Just understanding that is going to help you with these kind of problems. Okay, understanding how that absolute value, just kind of how it works. To write the inequality, just to give you a little bit of a blueprint, okay, you're going to do the absolute value of x minus the ideal on this one length. That could be weight, that could be, the next one's weight, that could be a different kind of measurement, could be volume. X minus the ideal weight is less than, on this specific one, it's going to be less than or equal to. Some of them might just be less than, but you're not going to see one that's talking about greater than. Okay? And you just got to look at the wording to figure out if you got the equal to or not. Less than or equal to the error allowed. So I was going to talk about how the ideal measurement can vary by this certain amount. So on this one right here, what is the ideal length of the necklace? 16. What is the error that the company allows? 0.5. And that will get you to the 15.5, 16.5 if you break it apart and find the two answers. Next class we'll talk about the inequality and what we'll need to do to that. Next class. So on this one it says a cereal company fills the boxes with cereal that are sold by weight. Each box should contain 32 ounces of cereal. The specifications allow for a difference of half an ounce. The function f of x equals the absolute value of x minus 32. It represents the acceptable difference between the weight of a box of cereal and these specifications. Graph the ideal function. What's the ideal weight? What's the error allowed? Okay, so writing that's all you got to look for, really. Okay? What is the ideal measurement, and what is the error that they are allowing?